VLAB itself is a fantastic community. There are brilliant people all over in this room, and the next billionaire is certainly in this room. There are a lot of beautiful, wonderful ideas that come out of here, and I got to be honest, I mean, really take advantage of this community, and doors will start opening. I really believe that strongly.
Patrick Ehlen, I'm Chief Scientist at Loop AI Labs, which is an AI company in San Francisco that we founded in 2012. And so we became a company that provides an AI platform, basically. My background is actually in cognitive psychology. I did not really study computer science, but I grew up programming and studied psychology of language and went from there to being sort of involved in speech recognition at AT&T Labs and natural language understanding. I actually did a postdoc here at CSLI right down Panama Street here. And I'm glad to be back.
So the slides are working now, but thank you for introducing yourself, Patrick, because he's actually speaking right after me. So now you already know who he is. You guys are going to hear from Patrick, and he already introduced himself, so you can get right into it.
Cool. All right. Thank you. Good stuff. So people ask me, all the time, what is AI? Because there's sort of, just what we used to think of as AI, like maybe speech recognition or even search engines are now just sort of technology. They're just tools. We don't really think of them as AI so much anymore. So AI is always kind of that thing that you're standing on the ledge between technology that we know exists and the stuff that maybe we can't quite do yet. And we can talk about, what can AI do now, and what can you do with your, enterprise business and investing with the AI of today. And we'll hear a lot about that tonight. It's also really interesting to think about what's AI going to be? Where's it going to go? So I've only got about 8 minutes or 10 minutes or so, but we'll just cover a few ideas that, to me, sort of lead to some basic questions that will maybe help us think of how we can expect AI to really change and really change our lives over the next 5 to 10 years, going beyond what we have now with deep learning and all of that stuff. So let's just start with humans. Who thinks we're special? Most of you? The rest of you maybe should call a psychiatrist. But no, why? What makes us special? I mean, I guess compared to plants and animals, other animals in the animal kingdom, what makes us special? Compassion. What else did I hear? Learning. But other we can lie. Yeah. That's a good one actually. We can behave like Trump. Yeah, we can wonder. We can reflect on our sort of place in the universe. I guess we don't know that other animals don't do this. Maybe ants, they're climbing up trees, look up and wonder about things, although I don't think they can really see that far. But I think, lying and compassion, we're starting to get at the things that make us uniquely human, because we know that there are certain things that are special about humans, even if we can't quite put our finger on it. There's some je ne sais quoi that we have that seems to distinguish us from other animals. So if I were going to make an AI system, and I might come to you and I say, I made this brilliant AI system and I've perfectly, replicated this intelligence, and you'd be like, wow, that's awesome, you're going to make $1 million. I'll say, yeah, I created an octopus intelligence. And I'd say, well, Patrick, that's really cool, but it's kind of not what we had in mind when we were talking about artificial intelligence. We don't want to recreate an octopus brain. We want to recreate a human brain, or at least the aspects of the human brain that are the most useful to us. So starting from that premise, you have to ask yourself, all right, so what are the things that we can do that are special to us that we would want a machine to be able to do? How does that distinguish from other things that we might be able to do with AI that are useful but don't really distinguish us as humans? So here's an example of some people playing Atari, and I'm sure you read, a few years ago, the folks at DeepMind did some really brilliant reinforcement learning AI stuff where they got a machine to be able to play games like Space Invaders just by only looking at the pixels in every screen and then knowing every time it got an increased point. And every time it got an increased point, the system knew it was doing something right, and over lots of iterations, you got a machine that was able to play Space Invaders much better than a human could. Everybody who read that was like, wow, we're like really on the way to AI having an intelligence that's like a human intelligence. But you have to ask yourself, could we teach a monkey to play Space Invaders? You probably could, right? So it's an interesting achievement, but it doesn't really get at the heart of what makes us human and what makes our intelligence so special according to us. So there's what I call human-level intelligence, which is just intelligence that are things that we as humans can do, and it's great if we can get machines to do them, like recognizing faces, detecting pedestrians so you don't run into them with your car, the infamous Turing test. So those are all things that we've seen a lot of accomplishment on just over the past 5 to 10 years. Going forward, I think we're going to see a lot more accomplishment in what I would call intelligence that more gets at the human capacity. And when I say human capacity, I mean those things that we're really good at that other animals can't really do, that we uniquely excel at. Which would be what? Please tell us. Well, the main one I think is manipulating symbols. Whether we're lying or doing creative things, that type of thing. Now there are lots of other animals in the animal kingdom that seem to have some sort of symbol manipulation going on and some form of communication. But there are certain things that only humans can do that we don't really see in communication systems in the animal kingdom, and I'll explain those to you really quickly. I didn't make this stuff up, by the way. An anthropologist did back in the 80s, a guy named Marshank, and he was picked up by a few other anthropologists along the way, and it eventually made it into a paper that I'll show you in a second that included Noam Chomsky on it. And so if you want to read more about this, you can go back to those papers. But the question really being asked in this original paper was just sort of, what about symbol manipulation seemed to happen that gave us this human capacity that we have. So there are a few things that we seem to be able to do that you don't see elsewhere in the animal kingdom. And one is to communicate multimodally. So when I say multimodally, it's, I can talk to you like I'm doing right now and communicate to you through an auditory channel, or I can write you a message and, communicate to you through a visual channel, or I can talk and I can point to things and gesture at the same time, and you have the capacity to integrate that. Basically, any message that I can say in one mode, I can say in another mode, and we're actually so good at that people who have completely lost the primary channel of communication, being able to, to hear, are able to communicate in a completely different language and a completely different mode that's just as semantically rich as what we're able to do with our primary communication channel. So that's called multimodal communication. It's one of the things that only we seem to be able to do. Another one is to embed and recurse over long sequences, and this is not just with language, but with all kinds of symbols. But allows us to say things like, this is the rat that ate the malt that lay in the house that Jack built, and you can understand that perfectly well, even if you've never heard that sentence before. And this leads to what von Humboldt called the infinite use of finite means, which means that we might have a limited number of sort of atoms that we can use to communicate with, but with those we have an infinite number of messages that we can produce. And we don't see that, as far as we know, yet in the animal kingdom. I'm going to wrap up here in about 2 minutes. But so it's these three things. This is the Hauser and Chomsky and Fisk paper here that I was talking about. That's from about 2003 or so. You can read more on that there. Just one quote I pulled out of there. We must thus conclude that the immediate ancestor of modern humans possessed a brain that had, for whatever reason, evolved to a point where a single developmental change or genetically related group of changes was sufficient to create a structure with an entirely new potential. Which is very interesting because for some reason we evolved not too long ago into this creature that does all these weird communicative things that we do now, and we don't really know why. So I was going to go on for a bit here about pragmatics, but I don't want to take up too much time. Pragmatics is a field of study in communication that is an area that AI still has made very little progress in. So we have, speech recognition things. We have natural language understanding. You can say, hey, Alexa, what's the weather today? And Alexa will say, it's going to be 70 degrees or whatever. Or you can say, Siri, do I need my umbrella? And she'll tell you if you do or not. But if you say, Siri, where is my umbrella? You probably won't really get the answer that you're looking for. And part of the reason for that is we still don't have a good way to operationalize what we call pragmatics, which is just knowing what things mean in the right context. So here, if you can't read it, he's saying, tell the men to move out. Why, sir? The rents are too high, right? So he's understood the words right, but he's got the context wrong. The point there is we don't usually understand each other just by the meanings of the words by themselves. There are lots of situational things that come to play. There's a great example of that from Herb Clark here at Stanford, who had this quote in one of his books where he said, Max went too far and teapotted a policeman today. Now, his point is that we don't know what teapotted means here, but this is a perfectly sensible English question. And if you and I know a guy named Max and he makes ceramic teapots, then I could just be saying to you, oh, Max went and maybe for some reason I'm outraged about this, that he went too far. But even though you don't understand necessarily the semantics that those words are supposed to have, it's a perfectly sensible and understandable English sentence. This is important in enterprise organizations because they need an AI that can interpret signals within the context of their business and with the context of their business environment. And the contexts that business run in are multifarious. There are social factors, market factors, financial factors. All these things are constantly changing. And when these things are changing, the things that, the meanings of words and the meanings that they're being used in are also constantly changing. So machines that don't understand these things and aren't built with these things in mind are going to have troubles with these types of things. So these are the kinds of things that, at Loop, for example, we're working on basically an operationalization of pragmatics that goes into every machine that we lease out right now and allows organizations to have a machine with a cognitive computing platform that really understands, what their words mean within their context. Whoops, I was going to go back one and leave it on the thing with our slide there. But anyway, I'll stop there. Thanks very much. Start on this side?
Yeah.
Sure. Well, there are, especially in large organizations, lots of inefficiencies that are already going on, and AI just has huge potential to, close that gap in the inefficiencies. One of the things that we end up working a lot in sort of the customer service area. We tend to focus lately mostly on sort of fintech and insurance companies and stuff like that. But places where you've got customer representatives who, even if they have good search tools, they end up doing a lot of sort of information handling in a way that really makes them. Not an unnecessary middleman, but a middleman who has to do a lot more has to do a lot more work than you would really want them to do. You can make these people a lot more efficient by putting in cognitive computing sort of principles and robotic process automation and that sort of thing, and really making people much more efficient. On top of that, we have signals coming from, I call them signals, but information that's contained in all kinds of different legacy systems that is a goldmine of information of what is going on in your organization across different parts of the organization and then throughout different systems. And up until now, it's been too big of a job for people to really just come in and look at all of that, unless you really have the money that you want to hire a management consultant team to go through all these different legacy systems types of data and gain insights from them. But this is something that we can now do fairly simply with a cognitive computing appliance. And so for us, that's one area that we've seen a huge potential for big ROI.
Right, so Patrick is saying that you guys should all go out and build your versions of Autodesk's Ava, right?
That's one thing you could do.
So I would like to go to the next question, which is, a lot of companies want to use AI. They want to be effective with AI, but adopting AI the way that Facebook does it, or the way that H2O does it, or the way that Loop.ai does it, or the way that your companies that you want to invest into it is actually really difficult. So what have you observed have been the biggest barriers to entry with regard to adopting AI at an enterprise scale?
Yeah, that's a good one. I mean, we face that all the time when we get, sort of upper management that's, wants to get on the AI train, and, they're willing to allocate resources to it and bring us in. And, a lot of times we work with strategic partners like Deloitte or Accenture or somebody, and then you sort of get to the level of implementation where you're dealing not with the executives anymore, but the people who are actually doing the work in the company, and suddenly you realize that there are all these barriers in the form of legacy systems and data formats, and quite frankly, people at the management level worried that they're now involved in something that is going to make them replaceable now. And because of that, we focus a lot of the time. I mean, our system really is designed to help people, not to replace people, and to make them more efficient and to allow them to spend less time doing the sort of drudgery. Advantageous to them. So there's that, and then there's just the fact that data is coming from all kinds of different systems that who knows how old those systems necessarily are. They're coming from multifarious systems, or they've already implemented, like, let's say IBM Watson to do this, and they've got the Salesforce Einstein doing that and stuff, and now you need to deal with different formats of data coming from all kinds of different directions. So that is a challenge, and we've sort of designed our system to make it so it can learn as much as it can just from data in all kinds of different formats, without you really having to spend too much time, waste too much time on reformatting it in whatever, because if you need everything like dumped into a CSV file, or it has to come through Hadoop or something like that, then it's going to be a nightmare for the people who are going to have to work on it. Yeah.
Yeah.